Okay, for this tutorial, we're going to look at continuing with logarithms. So hopefully you've went over the previous section and you've practiced switching between index form and logarithmic form. There's a few more things I'd like to say that I haven't said yet about logarithms. First thing is when we do end up using the calculator, when you see the word log on the calculator, or anytime you actually write it in math, sometimes you won't see a base. You won't see any little value there. So if there's nothing there, that implies that it's base 10. So for example, if I had log base 10x, that's the same as writing log x. So if you don't see a base whatsoever, that you automatically assume it's base 10. It's exactly the same as when you see a square root. That's the same as it actually being the second root. We just never actually write that. So the second thing I'd like to say, you may have noticed on the previous tutorial I had a little axis with x, y, and didn't end up using it. I'll just quickly go over what the graph of y equals log x looks like. Now we're not actually graphing in this first topic, that'll come later, but just for your own interest. What the graph of it looks like is y equals log x, is there's an asymptote on the y-axis, so I'll just kind of put a sort of dotted red line here. And the log of 1 is equal to 0. So at 1, it crosses the x-axis. It goes down, so less than 1, it's a negative value going down, down to negative infinity. And on the other side, it's continuing to increase, but it's slowing as it's doing so. So it's always increasing, but the further you go out, the longer it takes to increase. And if I was to think of that, if I was to do an example with, let's say, base 10, which is the general base for it, if I have 10 to the power of 0, that equals 1. So that's that point I put right there. Use a different color if you want. That's that purple point right there. If I was to do 10 to the power of 1, that equals 10. So maybe on my graph here, if that's 1, the 10, I'll use a different color, that might be something sitting right around there. If I increase the power again, 10 to the power of 2, that equals 100. So now, in order to go up only one more value, so it's like the y value is 2. To go up one more value from 1 to 2, I now have to go from 10 to 100. So I'm already off of this page as to where that would be. So as we already know, y equals log x, so that's y equals log base 10 of x. If I was to change that into index form, that would be x equals 10 to the power of y. So y is really like the exponent in this case. So if I was to look at this and think about the spacing here, when y was 0, it was equal to 10 to the power of 0 was equal to 1. But to go from y equals 0 to y equals 1, I went from 1 to 10, so I increased by 9 units. But it's not linear, so in order for me to get from 1 to 2, y equals 1 to the second exponent, y equals 2, I've got to go from 10 to 100, so now it took 90 to get there. If I did it again, 10 to the power of 3, that equals 1,000. So now it's taking me another 900 squares before it'll even go up by 1. So this function above 1 is slowing down the whole time. It's always increasing, but it's increasing at a slower and slower rate as it goes. Now that's actually just a side note if you're interested, but we're not actually, so this whole thing right here is not actually part of what we're doing right now. I just wanted to give a little more background on the logarithmic function. Let's look at some more rules that we might need to use with logarithms. So, first rule is that if we have a log of something, so let's say it was log x, plus the log of something else, So let's say log y. And notice I didn't put any base in here, so that means this is base 10 in this case. Then that means that I can write this as the log of xy, means x times y. So that is only true when it is the same base. So log of some base and then a number plus log of the same base. So when we're adding logarithms of the same base, we can multiply the numbers and combine the log. Based on that rule, if I was to do the opposite, if I was to have log of x minus the log of y, then that would give me log x divided by y. And the third rule is that if we have some value in front of a logarithm, we can move that front value and make that log of x to the power of n. So n now becomes an exponent, and maybe just to be more clear, I'll put a bracket around there. It's not like log x all to the power of n. The n goes on the number that is being logged, so it's log bracket xn. So those are three important rules. I think I'll highlight them. So we've got rule 1. I'm just going to read through them one more time. So if I have the log of x plus the log of y, that's the same as the log xy. Rule number 2, if I had log x minus log y, that would give me the log of x divided by y. And the third rule is if I have some number, and we're going to call it n, times log x, that's the same as log bracket x to the power of that number, in this case n. So it might be worthwhile for you to write those rules down. It's a good idea to memorize them, although you will find them on a formula sheet. It doesn't hurt to memorize, though, as you're practicing this stuff. Let's do some examples using these formulas. So the first example we're going to do, let's do log 6 plus log 18 minus log 24. Alright, so if I scroll up here just a little bit, I'm looking at the first and second rules here. I don't see a base on the log, so they're all base 10, and the rule says that if I'm adding, I can times them, and if I'm subtracting, I can divide. And I can do that all in the same line. So I can have the log of bracket, the first one's addition, so that becomes 6 times 18, and then all divided by, since the next thing's minus, 24. And if I wanted to simplify that a little bit, 6 goes into 24 4 times, so that's the same as the log of 18 over 4, and we could write that as the log of 9 over 2 if you want to leave it as a fraction, or the log of 4.5. Let's do another example. Three log 4 minus 4 log 3. So if I want to evaluate this one, what we're going to do is move the exponents up. We're going to use the third rule here. So the exponent, these numbers up front will become the exponent. So I'm going to move both of them up. So that becomes log of 4 to the power of 3 minus log of 3 to the power of 4. And remember, now we're going to use the second rule, the minus one. So that's the same as the log of 4 to the power of 3, which is 64, divided by 3 to the power of 4, which is 81. Now, in the next exercise, they're only asking us to simplify, so go as far as what I'm doing in these examples. If you want to actually evaluate them, get an actual answer, you would want to hit the log button on your calculator, and since these are base 10, that's what it already is on the calculator, and then just put the values. So if I wanted to do the first example, the log of 4.5, I would hit log on the calculator and then 4.5, and that is 0.653212513, and maybe I'd like to write it to 2 decimal places, so that would be the same as 0.65. And if I did the second one, I would hit log, and then I'd use the brackets, 64 divided by 81, and I get negative 0.102, so I'm just going to write negative 0.10. And both of those would be to 2 decimal places. As I said, though, this next exercise isn't actually asking us to solve them, so they're not expecting you to write what I've just written in blue. They're happy with you to write, just simplifying it, the previous line above it. Alright, let's try a third example where they'd like us to break it up and go backwards. So maybe it's somewhat simplified. So let's say the log of c cubed over b. And they would like us to break it up, get the c and b separated as much as possible so that it's in terms of log c and log b. So the first thing I would do is I noticed that division, and if I wanted to go backwards with rule number 2, I could write the log of c cubed minus the log of b. And then the final step is since I want it in terms of log c and log b, I don't want that cubed up there, so I could use the third rule and bring that back down out front. So 3 log c minus the log of b. And that would be the final answer going backwards. Alright, so give the next section a try. You shouldn't even need to be using the log button on your calculator yet, though, because it's not actually asking you to evaluate anything. That will be the next section where we're actually solving for things that we'll actually start using the log button on our calculator. Thanks.